Hey guys, so today is part 2 of our permutation and combination. So pretty simple, and that's my introduction for today. Pretty easy, right? For permutation versus combination in this video, and hopefully you watch my first video, you should know about the tree that I'm talking about. For each situation, that's what I want you to envision or remember this tree. Okay, at the end of this video, I'll make a tree that's simpler for you to remember. But basically, is it combination or permutation when you first started out, and then determine the formula based on the path of each tree. So let me show you here. So the coach wants to select, this is the first example, the coach wants to select 5 starters from 12 players. How many different ways can the coach choose the starters? So basically there are 12 players, okay? So the coach wants to just randomly select 5 to start the game, okay? Because I guess each players are equally good for the 12 players. But, okay, so let's first determine whether this is permutation or combination, okay? And then we can get rid of one of them, okay? Permutation is when order matters. What I mean by that is, does it matter if he chooses player A, B, C, D, E, for example, out of 12 players, versus if he chooses player A, B, D, E, C? No, right? Because they're still the same 5 people. I don't care about the order. The order doesn't matter, right? So in this case, we can clearly get rid of that side. We no longer need the permutation, but because we know that it is a combination for this problem, okay? So we know that there are a total of n equal 12 players. We can choose 5 out of those and make a team, right? So the question asks how many can you make? How many teams can you make with that, basically, okay? So now we got the next thing we know that is combination already. So we're good. There's no order. Now the next thing we need to go down and ask ourselves is, can we repeat the number of players? So for example, if Pete is on one of the team, you can't have Pete start 2 position, right? So no, you cannot repeat. So there's no repetition in this one, right? So clearly we can get rid of this branch altogether. So there's no confusion, okay? So if we got rid of that, the only thing we have left now is this formula right here, okay? What does that mean? That means all we have to do is substitute the value in. We should be able to find out what the answer is. So in this case, we get 12 factorial, because that's the total number of players we can choose from. And we only want 5 of those players. So 5 factorial times 12 minus 5 factorial. Okay? This is just 12 factorial over 5 factorial over 7 factorial. Okay? And, you know, with the calculator, you can easily do this problem. Okay? Definitely should be able to do that by hand too if you need to. But from here, you can cancel the 7 factorial with the 7 factorial, and the result should be around, the result is 792 combinations. Okay? You can make 792 teams with that. All right? Let's take a look at another example. Okay, now we start out with the 2 branches again. Okay, so let's take a look at the question. How many ways can 3 different letters X, Y, Z be arranged, given that the letters can be reused to make the 3-letter arrangement? So basically, in this case, you are able to you are arranging 3 letters using all 3 letters. Okay, so the number of n is equal to 3, and x is also equal to 3. But the first thing we need to ask ourselves, does the order matter? Okay, so in this case, is x, y, z the same thing as x, z, y? No, it's not. There are different combinations of letter, right? So it just said how many letters can we rearrange. It never said whether or not we should repeat it. So we always assume that the order in this case matter. There are two different combinations, right? There are two different orders. X, Y, Z and X, Z, Y are two different options that we can have here. So in this case, order does matter because they're not the same thing, unlike the team, okay? So in this case, the order does matter. We know for a fact now that it is permutation because the order matters. Now, we need to see if there's repetition. Given that the letters can be reused, therefore it is repetition. So let's get rid of the no repetition part. And in this case, it's pretty simple, right? We have n equal to 3. And x also equal to 3. And we know that, again, we can repeat the letters, therefore it can be reused. So the answer is 3 to the power of 3. Should be 3 times 3 times 3 equal 27, right? Okay, and that's your example 2. Okay, that was the second example. Now let's move on to the third example. The third example will have two parts for those of you who are still confused. Let's see. For this question we have here, there are 14 boys and 13 girls in the class. If a teacher wants to choose exactly 4 students to head a debate team, how many ways can this be done? Okay, so in this case, let's take a look at whether it is permutation versus combination first. So remember, permutation, the orders matter. Combination, the order doesn't matter. Okay, so in this case, if you have A, B, C, D as in a team, it's going to be the exact same thing as A, B, D, C, right? So in this case, the order do not matter. So we don't care about permutation for this one. Okay, so that's how I take a look at it, right? So once again, in this case, if the team chose boy A, boy B, and then girl C and girl D, and then they would, let's say they were to switch those order, it doesn't matter, it's still the same team, right? So in this case, order doesn't matter, no order. Okay, so let's see, can we repeat? Anytime we have a team of some sort with real people, we can't really repeat the people, so there's no repetition. Okay, we can't repeat things, so let's get rid of that. So no repetition. Okay, so now we just realized that the only thing left is that we have this formula. Okay, so we have that formula left. We need to find out what's n and what's x. Okay, so n in this case is equal to 27. We don't need to distinguish between boys and girls because in this case they're just saying we're just going to choose 4. It didn't specify whether or not it's going to be boys or girl, right? So there's no difference. So n is equal to 27 and then x is equal to 4. So because we only want 4 people out of 27. So then our formula would then, our solution would be 27 factorial over 27 factorial, 27 minus 4 factorial. And this is going to be multiplied by 4 factorial. Okay, so that should be your solution. Okay, now let's take a look at the part B of this. So we're going to do the same thing again, but we already know that in this case permutation is not it because the order doesn't matter. And we also know it's because it's the same problem, that repetition, we can't really repeat people. So we need 4 different people. So in this case, combination, it is combination, order doesn't matter, there's no repetition, right? And again, but for this scenario, it's a bit different. Based on the problem, it says the rule changed in 2013 with a debate team of 4 must have at least 2 girls and 2 boys. How many possible combinations? So we know that there are 14 boys in the class. So again, this is from the previous problem. And then we have 13 girls in the class as well. So combined for 27 people. So we want at least 2 girls and 2 boys. So that means that we have to have 2, and then we have 2 on each side. Okay, so in this case, we gotta look at each separate situation. So then we have n is equal to 14 on this side, and then x is equal to 2 here. Okay, and on this side we have n is equal to 13, and then x is equal to 2. Okay, so for this situation, if you want to look at it symbolically, it's basically C14, 2, and then combination 13, and you pick 2. Okay, and remember that since this is n, we gotta multiply. So we gotta multiply those 2 together. So basically, we gotta use this equation twice. Okay, so it's 14 factorial over 2 factorial, 14 minus 2 factorial times 13 factorial over 2 factorial and 13 minus 2 factorial. Okay, so that is a solution for that one, and remember, make sure you got to take these 2 separately because there are 2 different sides to this question. Okay, now let's see. Now that we're done with those exercises, I want to give you guys some problems to do on your own. Make sure you pause the video and then take a look at those and try to do it on your own on paper or something, and because I'll give you the solution right after. Okay, guys, let's start with the first solution for the the solution for the first exercise. So for this one, we know that there are 16 pool balls, and we want to arrange them, arrange all 16 of them. How many ways are there? So of course, for this one, for A, you should know that there's a lot of combination, right? A lot of ways you can order this. So for this one, let's first determine whether it's permutation or combination. So for this one, we know that, for example, if you have pool ball in 1, 2, 3, for example, you arrange the ball that way, all the way through 16 in numerical order. It's going to be different if, let's say, I arrange all the way through 16, but then I switch the order of 15 and 16, right? So I switch the order of 15 and 16 and just do 16, and then the other ball is 15. So in this case, we can tell right away that order does matter. So when orders matter, we go to permutation side, okay? And in this case, we can't really repeat, because once you use the ball number 1 or ball number 16 or ball number 15, we can't use it again. So the formula we have to use for this one is x factorial, n factorial over n minus x factorial, right? And n being the total number of balls, x being the number of balls we want to order. So in this case, the answer would just be n is 16, so therefore it's 16 factorial over 16 minus 16 factorial, right? Because in this case, we're choosing all 16 balls to order. Okay, So it turned out to be 0 factorial and then 16 factorial over 0 factorial. Oh, I forgot the factorial sign here. But 16 factorial over 0 factorial. In this case, we know that 0 factorial, hopefully make sure you get, if you guys don't know it already, make sure that you memorize that 0 factorial is always 1. So the answer would just be 16 factorial. Okay? For A. Alright, and that's this problem right here. We finished that, so let's get rid of it so it doesn't get in our way. So let's get rid of the solution here. Okay, for B, we have the exact same problem except we're only going to choose 4 out of 16. So again, we already know that this is permutation because the order matters. So for B, it should be pretty simple. It's 16 factorial over 16 minus 4 factorial. Okay, so we should get 16 factorial over 12 factorial. Okay, so we should just get from 16 times 15 all the way to 13, right? Because it cancel out with the 16 times 15 times 14 all the way to 13, and then you get multiplied by 12 factorial. So that cancels out with the 12 factorial. Okay, so you get 16 multiplied all the way to 13. So that's the answer for exercise number 1, the question B. Okay, now let's go on to question 2 of the exercise. Alright guys, let's get started on the answer for exercise number 2. You can see that John has 15 different types of ice cream, but he let you choose 3 out of those for each scone, right? So in this case, remember the first thing we gotta do is determine whether it's permutation or combination. So in this case, let's reason it out. So let's say I choose 3 scoops, and I choose vanilla, strawberry, and chocolate. Is that going to matter versus chocolate, strawberry, and vanilla? No, absolutely not. I don't really care because I'm gonna, eat all 3, even if it's in this different order. I don't really care, right? So order in this case does not matter. If order doesn't matter, I mean some guy's too cool. That means that it is combination, right? If you don't know what I'm talking about, please watch part 1, and you should know what I mean by C is cool. Okay, so combination. Now next, we got to determine whether we can repeat it or not. In this case, his only rule is that you can have 3 scoops. Doesn't say whether or not you can have chocolate, 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 vanilla, vanilla, vanilla. I don't think he would eliminate that because what if customer wants that, right? So in this case, you can repeat. Okay. So based on this information, we know that our equation should be n plus x minus 1 factorial over x factorial n minus 1 factorial. And again, if you don't know what this came from, watch part 1. In this case, we know that n is equal to 15 because that's the max number of flavor that we can have. X is equal to 3 because that's the amount that we can have out of 15, right? And that we should be ordering. So in this case, we get 15 plus 3 minus 1 factorial over 3 factorial times 15 minus 1 factorial. Okay, so in this case we get 15 plus 3 is 18, 18 minus 1 is 17 factorial over 3 factorial times 15 minus 1 is 14 factorial, so we get 3 factorial over 14 factorial. Okay, so this we can actually simplify to 17 times 16 times 15 because the and then that's 14 factorial up here. 14 factorial times 3 factorial, which is 3 times 2 times 1. So our answer, since those cancel, should just be 17 times 16 times 15 times 3 times 2 times 1. Okay? Anyways, those are the solution to the examples or the exercises that I gave you toward the end of the video. I hope it is a bit clearer now the difference between permutation versus combination. And so sometimes, like I told you before, it is fairly confusing for you to do these kind of problem at the beginning. But first, you gotta be able to distinguish which one it is. If you're able to do that, then it shouldn't be a problem. Okay? Good luck, guys.